So hello everyone, welcome back to our daily LeetCode challenge series. So today is day 96 and today we are going to solve LeetCode problem 441 arranging coins. Okay, so this is an easy level problem. So let's see the problem first. Okay, so you have n coins and you want to build a staircase with these coins. The staircase consists of k rows where the ith row has exactly ith coin. Fine. So the last row of the staircase may be incomplete. Quite obvious, right? So given the integer and return the number of completed row of the staircase you will build. Fine. Okay, so we have given input 5. So staircase basically every stair will have an ith value, right? So 1 will have 1, 2 will have 2, and 3 will have 3. But as we have only 5 bricks, let's say 5 bricks here. So one brick is going to be missing for the third one. That's why we are going to return 2. 2 is like basically we are taking it as index wise. So second we are returning, fine. Same example has been explanation has been given because of third row is incomplete, we are returning 2. Fine. In example 2, we have input as 8. So let's take 8 bricks. Okay, so 1 will have 1 brick, 2 will have 2 bricks, 3 will have 3 bricks, but 4 is not having 4 brick because we only left with 2. So 2 is missing. So we basically have to tell which stair will or which floor will have the lesser brick or incompleted one. So in this case, we can say 3 is the one. So 3 are going to return, right? Fine. So in constant we have given and can be vary from 1 to 2 to power 31 minus 1. Fine. Okay. So it's bigger than the teaser range. Also. So if you understand this pattern, okay, basically we will get this and value by doing the sum of this, right? So 1, then 2, 3, right? 3 basically minus 1 we have to return. Fine. As per the 0 index. So if we see the pattern, like we basically need the max sum of k here. Okay. So if we do sum of 1, then 2, 2 plus 1, 3, 3, right? And 3 is 6. So basically quite less than the maximum sum. So we can say if you're aware about the formula for the nth sum of the integer value, like natural numbers from 1 to till n. So formula basically we have n into minus 1 by 2, right? So this will give the value of k that basically we want, which should be lesser than or equal to our n value that is given. So that basically we need to find. If I tell the example, so basically we have to do the sum. Okay, let's say till n. Okay, not n here. We can say k, and k will be the one that we need to find. And here k we can say k will be equal to this sum like n into n plus 1 by 2. So it will give the total sum till the n natural number, right, from 1. So basically in this case we have to find that point. That point means like x should and k should be less than or equal to our n, right? This condition basically we have to satisfy. So in order to do that, like I believe like we can use binary search here, right? So that will be optimal one in this case. Okay, so let me implement that one. So let's use the binary search logic here. So I'm going to take left pointer or say left index at 0. Let's take right at n. N is our maximum one, right? So basically we are going to do the binary search. Binary search is the sum basically we are going to find. So we'll do while loop while so it should run till left is less than or equal to our right value, right? Now what we have to check here, we have to first find the mid, like basically binary search. So and let's say int mid, or we can take long here. Okay, as the range is like can be exceed, so we'll use left. then right minus left by 2. So this is the basically mid formula for binary search one, right? And now we will find the k value. K value is none other than the sum of n natural numbers, right? So that will be our mid to mid plus 1 by 2, right? So this will be our the sum of n natural numbers, right? Now we have to check if the k is equal to our n. Then in that case, what we'll do? We'll return the n here itself, or we can say mid here itself. So mid is the one that where the stair will not to be completed. But if it is not so, then we will check if our k is less than the value of n. Then what we'll do? We are going to increase our left one. So left will become mid plus 1, right? Else, if it is greater, then in that case we were going to decrease our pointer. So we'll make right equal to mid minus 1. Okay, so this will like we are going to let make it in bracket also, otherwise it will give some text error. So to avoid that, right? Fine. So by this way, like we are going to get that midpoint, and at last, what we'll do? We'll return our right index, right? As it should be in. So what we'll do? We'll just do typecasting here. Okay. Okay, fine. So here also we have to make it integer because return value is integer only. So we have to return. Let me remove this part. Okay. Now let's submit. Hope it will work. Okay, so our both test cases got accepted, right? As the expected output we are getting. Now let's submit and see for other test cases as well. Okay, cool. So our all 1036 test cases has been passed and beats 100%. So like our solution is quite optimal because anyways we have used binary search here, logic here. Okay, so the time complexity we are using in this solution is big O of log n. Okay, and space complexity is 1. We are not using extra spaces at all here, just constant spaces. Okay, so this is all we need. If you know any another approach other than this binary search, then you can just comment it down. Okay, yeah, so that's all for today. Let's see you next video. Bye.